This is problem 13 on page 186. It asks us to identify the open intervals on which the function is increasing or decreasing. We know in order to find the intervals of where a function is increasing or decreasing, we will have to find the critical numbers, which means that we'll find the derivative of the function and then set it equal to 0 and solve for x. One of the things that we also need to pay attention to as we're looking at the behavior of any function is you need to know what the domain of the function is. As I'm looking at this function, I see that it involves a radical. And remember, when you have a square root, you don't want whatever is under the square root to be less than 0. You don't want it to be negative. Whatever is under the radical has to be greater than or equal to 0. In order for this to happen, your interval would have to be between negative and 4, including negative 4 and 4. Because if I plug in a negative 4, I'm going to have 16 minus negative 4 squared, which is 16. That's going to give you 0. That's okay. I can have 0 under the radical. The same thing with 4. If I plug 4 in, I'm going to get 4 squared, which gives me 16 as well. So 16 minus 16 is going to give me. I have no problems with that. The problem comes when I plug in a number that's less than negative 4 or a number that's greater than 4. For example, if I plug in x equals a negative 5, what's under the radical becomes 16 minus a negative 5 squared. Well, that's the square root of 16 minus 25. And I know that that gives me a negative number. That cannot happen. So I know that negative 5 or anything that's to the left of negative 4 will not work. The same thing applies for anything to the right of positive 4. It will not work either. Okay, now that we know the domain, it helps us so that when we are finding values, we don't have to waste our time using values that we know are not going to work. We know that all of the values of x have to fit within this interval here. Now we're ready to take the derivative. The derivative of y is going to be y prime, and that's going to be the first times the derivative of the second. Don't forget to use the chain rule here, plus the second times the derivative of the first. I know that looks kind of ugly, but doing a little bit of algebra will help us to simplify this. I can multiply these two together. That gives me a negative 2x squared. I'm left with times 1/2. 16 minus x squared to the negative 1/2. I can multiply or cancel I should say, these two together. Let me go in and put this. And I'm left with a negative x squared in the numerator. This negative exponent I can make a positive exponent by dropping it in the denominator. And I'm just going to go back and write it as a square root. And on the right side, after the plus sign, I have that. So here we have the derivative of our function. Now we need to look to see what values of x are going to make this equal to 0 or make it undefined. The function, if you look at it, is undefined when your denominator is equal to 0. So I have a fraction, and I want to look to see where is that equal to 0. It's going to be equal to 0 at the endpoints of our domain. So I know that y prime is undefined at x equal plus or minus 4. So I know that plus or minus 4 are critical numbers. In addition to this, we need to find out where is this function equal to 0, or where is the derivative equal to 0. So we're going to solve negative x squared over the square root of 16 minus x squared plus the square root of 16 minus x squared equals 0. First thing that comes to mind is to isolate the radicals. So I'm going to add, or I'm going to subtract the square root of 16 minus x squared on both sides. I end up with negative x squared over the square root of 16 minus x squared equals negative the square root of 16 minus x squared. From here, I'm going to multiply both sides by the denominator, the square root of 16 minus x squared. And when I do that, I end up with the square root of 16 minus x squared times negative x squared over the square root of 16 minus x squared equals negative the square root of 16 minus x squared times the square root of 16 minus x squared. My denominator cancels out on the left side. I'm left with negative x squared equals, when I multiply these two together, my radicals cancel. I have negative 16 minus x squared. Here, I can just divide both sides by negative 1. I end up with x squared equals 16 minus x squared. If I add x squared to both sides, I end up with 2x squared equals 16. Divide both sides by 2. X squared is equal to 8. Solving for x, I'd have to take the square root of both sides. But whenever you take the square root of both sides, you have to include a plus or minus sign. So I know that x is equal to plus or minus the square root of 8. You can write this a couple of ways. You can write it as 2 the square root of 2, or you can approximate it as a decimal, which would be plus or minus 2.828. So our critical numbers are negative 4, negative 2 the square root of 2, 2 the square root of 2, and 4. These numbers split our real number line into several sections, or several intervals. We'll now set up our table so that we can put these intervals in the table, find our test values from those intervals, and we want to determine the sign of the derivative so that we can determine the behavior of the function. Is the function increasing or decreasing on that interval? So here are the intervals that our critical numbers give us, and we're going to pick some test values within these intervals. So this interval here, let's maybe pick a negative 5. Here we can pick a negative 3. Here we'll pick 0. Here we'll pick a positive 3, and here we'll pick 5. So we're going to plug those values into our derivative, and we're going to see what is the sign of our derivative. Notice that if I plug in a -5 into our derivative, or anything from the interval from -infinity to a -4, well, that's going to make my derivative, what's under the radical, a negative number. So we are unable to get a value. There's no value of the derivative here. Our derivative, let me write it out here, is not going to have a sign. It's going to be undefined. Same thing over here. Our derivative is undefined. So there's no conclusion about the behavior of the graph there. And that's because, as we saw initially, the domain of the function goes from -4 to 4. So the function doesn't exist really for values outside of that interval. So let's plug in our other values between -4, or our test value, -3. When I plug in a -3, we get -3 squared over the square root of 16 minus the -3 squared, plus the square root of 16 minus a -3 squared. This gives me -9 in the numerator over the square root of 16 minus 9 plus the square root of 16 minus 9. I end up with -9 over the square root of 7 plus the square root of 7. Remember, our goal is to determine the sign of this value. So even though it involves square roots, just plug it into your calculator and you'll find that you end up with a negative number. As a matter of fact, it's going to be negative. If you write it as a decimal, it's going to be a negative 0.7559. But again, I just need to know what the sign is. It's negative, so the conclusion is that y is increasing or decreasing. Plugging 0 into our function, we get -0 squared over the square root of 16 minus 0 squared plus the square root of 16 minus 0 squared. I end up with 0 over the square root of 16 plus the square root of 16. Well, this is easy. The square root of 16 is 4. So I end up with 0 plus 4 gives me 4. I end up with a positive value. So I know that y is increasing. Plugging in a positive 3, I'm going to get the same value I got when I plugged in a -3, because we are squaring them and I'm going to get the same value. So I end up getting a -9 over the square root of 7 plus the square root of 7, and we ended up getting a negative value. So we know that y is decreasing. So here I'm going to put x's instead of a dash so that you don't think that it's a sign. Our conclusion is that y is increasing on -2 the square root of 2 to 2 the square root of 2, and it's decreasing on the interval -4 to -2 the square root of 2 and 2 the square root of 2 +4.